prevailing wisdom about almost all types of cancer is that the disease occurs due to a combination of genetic susceptibility and environmental exposures. For different types of cancers, the relative weight of each of these components may differ, but teasing out how much contribution to cancer incidence can be attributed to genetics versus environment is tricky. Unless, that is, you have access to a register of over 100,000 pairs of twins. In an article appearing in the Journal of the American Medical Association, researchers from 4 Nordic countries combined national twin registries to create a very detailed database of cancer incidence. The idea here is that identical twins share 100% of the genetic risk factors for cancer, whatever those may be, while fraternal twins share only 50%. This knowledge in hand, you can deconstruct just how much genetics is to blame for cancer. First, some numbers. 32% of the cohort would develop at least one cancer in their lifetime, a number which pretty closely matches what we see in the US. Now, if your fraternal twin developed cancer, your lifetime risk bumped from 32% to 37%. If your identical twin developed cancer, that lifetime risk went from 32% to 46%. Clearly, genetics are at play here, but how much exactly? Well, overall, the researchers estimate that about 33% of the variance in cancer incidence is due to genetic factors, with 0% due to shared environmental factors. Let's parse that a bit, though. The researchers are not saying that the environment has nothing to do with cancer. They are saying that shared environmental factors, those things that 2 siblings would experience together, don't account for much risk. Once you leave the nest, in other words, the environment can still play a role. In fact, just doing the math suggests that around 66% of the variance in cancer incidence is due to environmental factors, just factors that don't happen to be shared by 2 siblings in their youth. But as I mentioned, these contributions vary by type of cancer. For lung cancer, the shared environmental exposures accounted for more of the variance than genetics, probably because twins tend to share smoking habits, even at a young age. The important thing about this study is to realize that the genetic factor percentage puts a cap on what we can hope to learn from genetic studies of cancer. In other words, even if we perfectly sequenced everyone's genome, we'd only explain about 1/3 of the reasons why people get cancer. The smart money remains on evaluating environmental exposures, with the exception of some types of cancer that appear to have very high genetic risks, such as leukemia. I'd be remiss if I didn't mention that this study was done in 4 Nordic countries, and so the results probably don't give a complete picture of the risk faced in a more multi-ethnic society. In addition, the study can't answer the intriguing question of whether certain environmental exposures interact with certain genes to promote cancer. For now, we simply know that some of your destiny lies in your genes, but more of it in your actions. For MedPage Today, I'm Perry Wilson.